figure we're going to talk about is a pyramid. Okay, and the formula for the volume of a pyramid is 1/3 area of the base times the height, which is very similar to the volume of a prism. The reason behind that and why there's a 1/3 there, and that 1/3 looks really weird, is because if you have a prism and a pyramid and they have the same exact dimensions, same area of the base and same height, you can fit 3 pyramids of that same exact size inside that prism every single time. Okay? You might be wondering, how can you fit them in there? We have this thing, I don't know where it is, that's fine, but it gives you a better visual. But if you just look at these diagrams, we could squeeze another prism in this area and another prism in that area of identical shape and size. And that makes 3 pyramids in 1 prism. Okay, so that's why that's the formula for the volume of a pyramid. Okay, you're just finding the volume of a prism with the same dimensions and then multiplying it by 1/3 or dividing it by 3 to get the volume of that 1 pyramid. So again, you just have to be able to recognize that you have a pyramid and then use that formula. So that's why that 1/3 is there. Okay? So we want to find the volume of the following figures. They are pyramids. A lot of times what happens is we get prisms and pyramids mixed up. Okay? The difference between the two is a prism, what we talked about yesterday, had 2 bases. It had a base on the top and a base on the bottom. Okay? Pyramids only have 1 base. Okay? So here's the base of this pyramid. And then all the sides come together to a point. Okay? So pyramids are very pointy. Okay? Prisms have 2 bases, so that they're more rectangular looking. Okay? So, I know I'm finding the volume of a pyramid. I'm going to write the formula for the volume down. I know big B stands for area of the base. So I'm going to find my big B. Okay, what formula are we going to use to find the area of that base? What is the shape of our base? Not square, very close to a square. Rectangle. Not all the sides are the same. Okay, so what's the formula if you're trying to find the area of a rectangle? What would we use? Base times height. Okay? And if it helps, draw the base off to the side. So then you can kind of get a better idea what the shape is and what formula you're going to use, because sometimes it's hard to tell when it's in kind of that 3-dimensional formula. Okay? So when we find the area of our base, what are we plugging in for our little b? What's the base of our base? What's the height of our base? And then when we multiply those together, 6 times 4? 4. Okay? That's our big B. To find our h, okay? That is the height of your entire figure. This h inside this formula is just the height of your base. The h inside the volume formula is the height of the entire figure. Don't get those 2 mixed up. Another way of thinking about it, I use my 6, I use my 4. More than likely what's left is my height. And I know it's my height because it starts up at the point, drops straight down the middle of your pyramid, and it's perpendicular to the base. That's always your height. Your height always goes straight down, and it's always perpendicular to the bottom. Okay? So our height in this figure is 9. So now that we know our 2 pieces, plug them into that formula. So volume is equal to 1/3 area of the base times the height. So when your calculator would do 1/3 times 24 times 9, what do we get? What do we get? 72. Double check how you type that in. And we label it meters cubed. Okay. Questions over this? Okay. So again here, we have a pyramid. So I'm going to write down the formula for volume of a pyramid. Okay. Find your big B first. What is the shape of our base? A triangle. The base of our pyramid is a triangle. So what's the formula for finding the area of a triangle? Half base times height. And if it helps, draw that triangle off to the side. Alright, this part's 12, and that part is 8. Okay. When we find our big B, we have 1/2 times. What are we plugging in for our little? Oh, that's 10, not 8. So get a different figure. Thank you. What are we plugging in for our little b? What are we plugging in for our height of our base? 10, yeah. That's why I like to draw it so we don't get our heights mixed up. Okay? So then plug that in 1/2 times 12 times 10 is what? 60. So that's the area of our base. Okay? Then we have to find the height of our whole figure. When you look at that figure, what is our height? 17. Yeah, it starts at the point, drops straight down, and is perpendicular. Makes it 17. So now we know our two pieces. Plug them into the volume formula. 1/3 big B times the height of the figure. And what do we get? We do 1/3 times 16 times 17. What is it? 340? That's like, I heard it at the same time, so they kind of lumped together. Feet. Questions over that. Then you have to be able to identify the type of figure you have, write down the formula, and then use that figure to find what you need to find the volume. Question. If we take a look at example 2, it says determine the volume of the pyramid below. Round your answer to the nearest hundredth of necessary. I don't know why that's written there. Shouldn't have to, but so let's go ahead. We have a pyramid, so I'm going to write down that formula. I'm going to write it over here. Okay. We need to find our big B and the height of our figure. We find our big B. What is the shape of our base? Yeah, square. Well, both sides are the same, so it's a square. Okay. Again, if it's helpful, write it off to the side. So what formula are we going to use to find the area of our base? Times height. Okay. So what numbers are we going to plug in for our little b and our h? Base of our base, height of our base, 14 and 14. So what do we get when we do 14 times 14? Okay, so that's the area of our base. When we look at our figure, we have to find the height of our figure. And remember, the height starts at a point, the point, and drops straight down. And it's perpendicular with the base. Does it tell us what that was? No. What happens a lot of the time is this line right here, where this arrow is pointing, that dotted line, they're saying that's 25, but that's not the height of the pyramid. That's what we call the slant height. It's kind of what, how tall the side is, but it's not how tall the pyramid is because it's slanted and height is always straight up and down. Okay? So we can never use the slant height as the actual height. It happens a lot. We get them mixed up. The height always starts at the point and drops straight down. Okay? We talked about this a little bit yesterday. What do you think we're going to use to find our height? Something's missing. We talked about it yesterday. What do you think we're going to use? Something.
The only number we have.
What is it? Pythagorean theorem. Whenever something is missing with volume, you're going to use the Pythagorean theorem to find it because what shape did we just make when I did that? A right triangle. And if it helps, draw it off to the side. Okay? It said this slanted part is 25. We have no idea what our height is. What do you think the distance of this bottom part is? Yes, it's 7 because the height comes right down in the middle. So if the height comes down in the middle, it's going to be halfway of whatever this is. So if this is 14, right, cut it in half, so that bottom part's going to be 7. Which one has to be our C? 25. So go across from your 90, that's always your C. Then it doesn't matter, I'll make that my A, make 7 my B, and plug it in. So we get h squared plus 7 squared equals 25 squared. 7 squared is 49. What's 25 squared? What do we have to do with the 49? That's the 49. Okay. So we get h squared equals, what's 625 minus 49? 576. What do we have to do to both sides? Square root. And then when we do that, what does our h equal? 24. So that is the height of that entire pyramid is 24. Don't say 25, that is the slate height, the actual height. That height is always up and down and perpendicular. Okay? So now we know our two pieces, we know our height, we know our big B, we can plug it into our volume formula. So we do that 1/3 times 196 times 24 is what? Wait, what do you get? 1,560? 8. 68. And we will label that centimeters. And that is the volume of that pyramid. So again, when something is missing, use the Pythagorean theorem to find it. Sometimes, rarely, you will use trig. More than likely, though, you can use the Pythagorean theorem. If you flip it over, we're going to talk about another figure, which is a cone. We're very familiar with this shape. We often eat ice cream out of them. Right? It's exactly how it's done. It's a cone, like an ice cream cone, a paper cup you put a snow cone in, something along those lines. Right? A party hat, that is a cone. Right? The formula for a cone is 1/3 pi r squared times the height. Because, same concept with a pyramid. If you have a cone with the same exact dimensions as a cylinder, you can fit 3 of those cones inside that one cylinder. So that's why we just find the volume of a cylinder, divide it by 3, or multiply it by 1/3. And that will give you the volume of a cone. Okay? So we take a look at A. We want to find the volume of this cone. So write down the formula. And then we have to find our 2 missing pieces. Looking at your diagram, what is the radius of our cone? Yes. What is the radius of our cone? 7. Yeah, to figure out your radius, go to the base of the cone, which is the circle. The radius of that circle is 7, so the radius of our cone is 7. What's the height of the cone? Oh, yeah, same as a pyramid. It starts at the point and goes straight down. Okay? That's your height. So then you just take those values and plug them in. Okay? So when it says leave in terms of pi, that means pi is in your answer. You treat it like a variable. Okay? Can I see with the phone away, please? You shouldn't have that out. Thank you. We're going to do 1/3 times 7 squared times 12 in your calculator. What do we get? We do 1/3 times 7 squared times 12. 588. Everyone agree? So you would say 588 pi. We want to leave it in terms of pi. Do not plug pi into your calculator. And just write it as feet cubed. Because our direction said leave your answers in terms of pi. Pi has to be in your answer. You just plug in the numbers. treat pi like a variable when it's subject. Yes.
Yeah, it's 196.
Okay, didn't divide by 3. 196? There you go. Sorry. 196. Pi. I'm trying to remember answers from first period. Couldn't remember. Questions over that? We take a look at B again. We're finding the volume of a cone. Write down the formula. And we need to know what our R and our H is. Okay. Looking at that cone, what's our R? 7. Very good. They gave us the diameter of the circle. We only want to know the radius, so you have to cut it in half to get 7. What's the height of our cone? 18. So it starts at the point and it goes straight down. Plug them in. So plug in your calculator. 1/3 times 7 squared times 18. What do we get? We do 1/3 times 7 squared times 18. 294. And then tack on the pi. Because we want to leave our answer in terms of pi, so treat pi like a variable. And then how would we label it? Feet cubed again. Yes.
Cones, will we ever be given the slant height?
We'll see an example here in a second. Yep. So that's an example. Questions over that? That's a good question. We'll see that here in a second. Okay, we take a look at example 3. It says find the volume of the following cones. Give your answers in terms of pi. I'm finding the volume of a cone. I'm going to write down the formula for a cone. Okay. So let's find our pieces. We'll be looking at this diagram. What's the height of our cone? 15. Starts at the point. Straight down. That's 15. Did they tell us what our radius is? No. So when something's missing, what do we use? They didn't give us the radius, so what are we going to use to find it? Pythagorean theorem. When something's missing, we use the Pythagorean theorem to find it because we have a right triangle right here. Okay? And if it's helpful, redraw that triangle off to the side. We know this part, the slanted part's 17, the height's 15, but we don't know our R. That's what we're trying to find. So, again, our C is across from the 90. Make that my A and that my B, and then you plug it in. Right? So we get A squared plus 15 squared equals 17 squared. Plug it into the formula. And then solve. When we solve, we get R squared plus what's 15 squared? What is 17 squared? To get R by itself, what do we have to do with that 225? Subtract. So we get R squared is equal to what? 4. Square root both sides, so R ends up equaling what? 8. That is our radius. Okay? So again, when something is missing, you're going to use the Pythagorean theorem to find it. Okay? So we just plug it into that formula. We have all of our pieces. Plug them in. We get 8 squared times 15. So you're going to do 1/3 times 8 squared times 15 because we want to leave it in terms of pi. So what do we get? We do 1/3 times 8 squared times 15. 320? 320. There you go. 320 pi. And sorry, I meant to say this. Keep this in meters. I didn't want to convert. Just change that to an M. Technically, we would have had to convert if that was centimeters. So just change it to meters. We'll talk about converting stuff later down the road. We're not going to talk about it right now. And then. Question. One more. We get time to work. Questions over that one. Again, when something is missing, use the Pythagorean theorem to find it, then plug it into your formula. Last one. It says a cone has a volume of 108 pi cubic meters. If the cone has a height of 9 meters, what is the radius? Okay, so we're talking about the volume, we're talking about cone. So I'm just going to write down the formula for the volume of a cone. And they're asking us to find the radius. So radius can be the only variable. In our problem. That could be the only variable. Okay? So we have to plug something in for V and H. What are you going to plug in for V? 108 pi, because that's the volume. V stands for volume. So we'll plug the volume of the cone in for V. That's going to say pi is a number. It's just represented with a symbol, so leave that pi. We're trying to find the radius, so that's going to stay R. What can we plug in for H? Because that's the height. That's what it says, height of 9. So we're going to plug 9 in for H. Okay. And then we're going to solve for R. So what can we do on this side to kind of clean things up to start solving for R? What did you say? Yeah, good. You can multiply those numbers together. Good. Clean it up. We can do 1/3 times 9, which is 3. And then we're left with pi r squared. So kind of clean things up. Again, we're solving for r. We want to get r by itself. Okay, so it helps us to circle our box. It gives me a good visual of what I need to move over. How are we going to get r by itself? Good. Divide by 3 pi, because we're multiplying r by 3 and we're multiplying r by pi. So we're going to divide both sides by 3 pi. That way it cancels. That cancels. We're left with r squared equals, what's going to happen with these pi's? They cancel. And what's 108 divided by 3? 36. Is r by itself completely? No. What do we have to do to get it completely by itself? Square root. Very good. We got to get rid of that square. So we're going to square root. So when we do that, what's the square root of 36? So the radius of that cone, even though we didn't have the diagram that fed us information, we could still find it using our formula and solving for that missing piece. Questions over there? Whenever you're given the volume and you're trying to find a missing piece, you're just going to plug things into the formula and solve. If you're trying to find the volume and you're missing a piece, then you're going to use the Pythagorean theorem. Questions over that?